Hi guys, my name is Ashutosh Bansal. This video is an assignment for making a linear regression model to predict the price of the house in the Boston dataset. Okay, the first step is the import of the required modules. Here, the modules are this, and the second step is the data preprocessing. Okay, first of all, we load the data and by using the function load underscore Boston and give them a variable and assign them a variable name Boston. Okay, next we print the description of the data set. Here we see there are 506 data points which contain the 14 attributes. Here are the attributes. Next, it also states that there are no missing values. So that's cool. Next we make a feature. Then we make a data frame called feature data frame. Okay, which contains the Boston dataset and the name of the feature. Simply the values of the feature. Similarly, we also make a target data frame which contains the target data. Okay. Next we concatenate the feature data frame and the target data frame into a single data frame and give them a name of df. The third step is the data visualization. Okay, we use here the describe function. Describe function basically generates the descriptive statistics of the data set. It also excludes the null values. Here we can see all the necessary computations like mean value, max value, etc. Okay. Next, further we define the correlation function. Correlation function basically describes how values in one column is related to values in the second column. It shows which features can mostly affect the target value. Okay. Here we use the Pearson method. We take the absolute value of for the correlation function. We take the absolute value of feature and we further make a list and zip the correlation value and the list value in the feature. Okay, next we sort according to the absolute value of the feature. Here next we make a plot. We make a bar graph. We make a bar graph of size 15 and 5. Okay, where we give the x label to the attributes and the y labels to the correlation with the target variables. Then we show. Here we can see there are only two, means there are only two features that can affect the most, LSTAT feature and the RM feature. LSTAT feature is the status of the people, percentage lower status of the people, and the RM feature is average number of room per dwelling. These two factor impact the most in the final price of the house. Okay, our fourth step is the data normalization. Well, normalization makes the feature more consistent with each other, and it allows the model to predict the output more accurately. That's why here we use the min-max scalar, which is used for normalize the data. Okay. Min-max scalar takes a list of values in any arbitrary range and give a list in which values are in range 0 to 1. Here we can see the data set before normalization and the data after normalization. We can see values are assigned in 0 to 1. Okay. Next, we define the error function. It is very necessary to identify the loss function in our model in machine learning, because it is used to evaluate how well our model fits the data set. Okay. There are three types of loss functions that are present in the machine learning. First is the mean square error, second being absolute error, the third is cross entropy loss. Here we will be using the mean square error function because it is easy to calculate the gradient. First we calculate the error between the actual end value and the predicted value, which returns the actual value and the predicted value. Okay, next we split the data into two phases, training phase and the testing phase. Okay, Next, this is an update function. Update function changes the value of the slope and the intercept. Okay, this is the return values of m and c. Here, this is the formula for using the cost function, okay, for linear equation model. Yeah. Next step is to make a gradient descent function. Okay, this is here we pass the initial value of m and c, and also the value also assign them also pass the value of x, t, learning rate, iterations, and the error threshold. Error threshold is the minimum value of the error that can be acceptable. Okay. Then we make the two list of the error values for the error values and the MC values. Next we make an loop of iteration. Okay, each iteration it can update the value of e. E contains the slight changes in the value of mx and ct. Okay, if there is a, if value of e is less than the threshold value, then it prints the desired result and break it. And if it is greater than, then it can again starting from the initial value and move further. Okay, it returns this gradient descent function returns the updated value of m and c, and the mc values and error values. You can see it can return a two list and two values. Okay. Next here we assign the initial values of m and c, learning rate and iteration, and the error threshold. Here we gave the updated value of these four variables. Okay, by the use of this function. Next, our sixth step is the data visualize the learning process. Here we use the linear model. Linear model basically is a linear relation between the target value and the predicted value. Sorry, target value and the feature. Okay, here we make a plot of our data, extend data and the white training data, and give them a blue color. Here we plot it. Here we can see there are a lot of outliers that where our predicted value is not same. It can change very a huge amount. Okay. Next step is prediction. We make an object called predicted, and which contains a predicted value of m and c. Okay. Next, we calculate the mean squared error of the predicted value and the test value. Here we can see there are 0.022 values. This is the mean squared error simply. Next, here we make a data frame of the target and the predicted value, and we call the head function to show the top 5 results. This is the x, and here x is an attribute that have average number of rooms per dwelling. Okay, we see here we take the attribute rm for predicting the final value. We also take lstat value. It simply depends on you. Next we scatter the testing data and the predicted data. Okay, here we can see this the result is. Next, finally, the final step is to convert the price into $1,000. Means to simply to change this value into $1,000, so that we can actually tell the final value which will be calculated. Okay, here we will be reshaping our model, our x test, y test, and we use the inverse transfer function for this. task, and also we remove the extra dimensions that can be included, and here we see our final result. Okay, thank you.